Question 4. The graph below shows the variation in boiling points of group 16 hydrides. And we can see here, we've got water here with a high boiling point. These are all in Kelvin. So boiling point here around maybe 370, 380 Kelvin. And a drastic drop down to hydrogen sulfide and gradually increasing again through group 16 or group 6 of the hydride. So the hydride just means it's the element in that group bonded to hydrogen. So water could be is an example of a hydride. So again, just like with the other questions, don't be confused by some terminology that the questions might use. So the variation in the boiling point can be explained by intermolecular bonding. Explain why H2S has a lower boiling point than H2O and H2SE. So just like the previous question where we were looking at ammonia, fluorine and bromine, you are going to be cross-comparing different types of intermolecular forces. So we already know that water is a strange chemical in the sense that its properties are unusual because of the hydrogen bonding present. So we know in water there will be hydrogen bonding. Okay, so looking down to the rest of the chemicals, H2S, H2SE and H2TE. These will all have permanent dipole-dipole interactions. They're all going to be polar molecules to a certain degree because there's lone pairs on each of these elements here. So they're all going to be polar. But thinking about what else is changing here, the other attractions, the London forces that are going to be forming between these molecules will change due to the numbers of electrons. So this question, the answer to this question is very, very similar in structure to the previous one about fluorine, bromine and ammonia. Okay, so what can we say here? Mark number 1, water has hydrogen bonding. Okay, so it's stating the type of forces present in the water molecules. Okay, and the reason why its boiling point is so much higher than the rest, the second mark, a very clear statement, is the hydrogen bond. The hydrogen bonding is stronger than the London forces present in the other molecules. Okay, so that explains that huge decrease from water to hydrogen sulfide. Okay, so mark number 3, we're now going to look to try and explain why H2S is lower than H2SE. So we've explained why it's lower than water, so why would it be lower than H2SE? Okay, well, we're going down the group. Selenium has more electrons than sulfur, so selenium can form more London forces than sulfur, and therefore it will take more energy to overcome. And that'll be your final part of this question. So you can say that H2SE has more electrons than H2S. This means that the London forces will be stronger, and more energy is needed to overcome them. So again, as I mentioned before, any explanation, any answer where you're trying to explain trends and differences in boiling points, you must try and bring your answer back round to this idea of the amount of energy needed. And you could approach this question from the alternative perspective, and we could talk about H2S having fewer electrons than H2SE, meaning there's weaker London forces and the energy needed to overcome them is lower. It doesn't matter which direction you take it from, as long as you fully explain in terms of electrons what's going on. Part 2. Polonium is at the bottom of group 16. Its hydride has the formula H2PO. Estimate from the graph the boiling point of H2PO. The relative molecular mass of H2PO is 211. So this is the one then, this question, you've got to do a bit of extrapolation, a bit of mathematical work on the graph. We'll bring the graph back up again now. So we're told that H2PO has got a relative molecular mass of 211. So we've got to find where that would be on the x-axis. Okay, if we look at what's happening here, We're going up in 40s across the big divisions there, and so we could argue then that each 2 boxes is going to be roughly 10. So 210, 220, 230, 240. It's not a particularly accurate scale, but your 211 is going to be around this point here. So taking from here, we can guesstimate then that your H2PO is going to be somewhere in this region here. Okay, so if we continue the pattern of the line, we can see we're gradually stepping up. So you can argue then that your next one is maybe going to carry on going up like that. So you can see the line is continuing to curve, and we can go around there somewhere. So where you across the 211 line, you've got this sort of region here. So any of these sort of guesstimation questions, you will have a range in which you can fall within. Okay, so I would go for some kind of extrapolation from there. So you're drawing your line back from where the last point is, trying to continue that line, and you could even go between this point here and draw a straight line like that, and from this point carrying on the direction of this line going up to where I am there, and then falling somewhere within this range. Okay, so maybe pick the middle value around there. Okay, that's coming at about 330. Okay, so somewhere around the 330 mark would be an answer for that one. And the mark scheme's range gives you between 285 and 335. So I've gone towards the top, the higher end of that range. Okay, so it's a bit of mathematical skill in trying to interpret and extrapolate the graph.